So network layer, module number 4, introduction to network layer. Layer 3 is your network layer. So layer 1 is my physical layer. Layer 2 is data link layer. Layer 3 is network layer. Layer 3 manages, that is the network layer manages device addressing, tracks the location of devices on the network, determines the best path to move data from source to the destination based on network conditions. So based on the various network conditions, it will determine which is the best path to move from the source network to the destination network. So it will decide which is the best path to move from the source to the destination. The priority of service and other factors. Network layer is responsible for routing and forwarding the packets. What is routing? Routing means when you want to communicate between two nodes. Communicate between two nodes. Communicate between two nodes. We say that it is routing processor. What will routing do? When you want to communicate between two nodes in a computer network, then it will choose which is the best path. Routing will choose the best path from the source to the destination. So network layer is responsible for routing, that is communication between the two nodes in a computer network when you are traveling from the source to the destination, and forwarding the packets. Routers are the layer 3 devices. They are specified in this layer and used to provide the routing service within an inter-network. So routers, they are the network 3 devices. So in the network 3, that is in the network layer, in the layer 3, that is in the network layer, you find the routers and they are responsible for providing you with the routing services. The protocols used to route the network traffic are known as network layer protocols. So the protocols which are used to route the network traffic are known as network layer protocols. Example, IP. What is IP? Internet Working Protocol. IP is Internet Working Protocol. IP is said as Internet Working Protocol. So network layer. The network layer is responsible for the source to destination delivery of the packets. So it is responsible for source to destination delivery of the packet. What is a packet? Packet is nothing but a data. So this data is divided into smaller chunks, and these smaller chunks are called packets. So data is divided into smaller chunks, that is number of packets, and then it is delivered to the transport layer. So the network layer is responsible for source to destination delivery of packets, possibly across multiple networks. So let's see this diagram. From the data link layer, what will happen? From the data link layer, it will receive services. Who will receive services? The network layer will receive services in the form of packets, which are small chunks of data. So it will receive services from the data link layer. The services will go to network layer and transport layer. Network layer provides services to the transport layer. Network layer provides services. So it receives the services from the data link layer and it provides the services to the transport layer, because in between you have the network layer. So network layer will what it will do? It will receive the services from the data link layer in the form of packets, and it will provide the service to the transport layer. Also from the transport layer, it will take the information and it will give it to the data link layer. So functions or design issues of the network layer. First is packetizing. What is packetizing? Packetizing means nothing but small packets, that is small chunks of data. Small chunks of data. Small chunks of data will be taken in, will be there. So dividing the data into small chunks of data. That is nothing but you are dividing the long message into smaller message. That is the function, that is the packetization. So what is done? We will encapsulate the bigger size data into packets at the source and then decapsulate at the destination. So the bigger size data is encapsulated at the source and then it is again decapsulated at the destination. So what is packetization? Breaking small chunks, breaking the bigger data to small chunks of data. For example, if there is a image, you will break that image into smaller images. So there is an image, you break that image into smaller images. Then when you reach the destination, you will again join it to form that bigger image. So packetization is nothing but dividing the bigger message divide into small message. So network layer receives the data units from the upper layer and converts them into packets. This process is known as packetizing. It is achieved by internet protocol. So it will receive the data units from the upper layer, that is from the transport layer. It will receive the data units and then it will convert them into packets. This is called as packetization. It is achieved by the internet protocol. Internet working. An internet working is the main responsibility of the network layer. It provides a logical connection between the different devices. So what is internet working? To connect multiple computer networks. You want to connect multiple computer networks. What do you use? You use internet working. Now addressing, a network layer adds the source and the destination address to the header of the frame. Addressing is used to identify the device on the internet. Why are you using addressing? To identify the device on the internet. When a packet has to travel from one network to another to get to its destination, many problems can arise. So when a packet is traveling from one network to another network. So what is addressing? First let's see what is addressing. Addressing is nothing but you are adding some address. So for example, it is a unique number to identify a host or a machine. Addressing is nothing but you are adding a logical or a physical address to uniquely identify a host or a machine. For example, in case of a telephone number or a phone number. What is the phone number? The phone number is a unique number. Every person will have a unique phone number. So that person you can call him or her using that unique phone number. So that is all about addressing. Addressing means having a unique number to identify a host or a machine. So when a packet has to travel from one network to another to get to its destination, many problems can arise, such as the addressing used by second network may be different from the first network. The second one may not accept the packet at all because it is too large. So what is packet? Packet is nothing but smaller data chunks. Smaller data chunks. But it can happen that though you have reduced the size of that message, but still it is too large for the second one, the second network. The protocols may different and so on. It is up to the network layer to overcome all these problems to allow heterogeneous networks to be connected. Now, logical addressing. In order to identify each device on the inter-network uniquely, network layer defines an addressing scheme. The sender and the receiver's IP addresses are placed in a header by the network layer. Such an address distinguishes each device uniquely and universally. So what does it do? The network layer on a header, it will have the sender address as well as the receiver address. So the sender address should match with the address at the receiver's end. If it matches, then you say that the flow of data has been occurred. So such an address distinguishes each device uniquely and universally. What is routing? Routing is a major component of the network layer and it determines the best optimal path out of the multiple paths from the source to the destination. So suppose you have A, B, C and again B. So what will routing do? Suppose from A you want to send data to B. It will decide which one is the best optimal path. So going directly from A to B is best, or from A to C to B is best. From A to B you can go, or you can go from A to C to B. So which path is best for that data? That will be decided. Is AB best or is ACB best? Which path is best for the data to travel will be decided by routing. Out of the multiple paths from source to destination, your source is A and your destination is what? B. Congestion controller. If too many packets are present in the subnet at the same time, then they will get into one another's way, forming bottlenecks. The control of such congestions also belongs to the network layer. Moreover, the quality of service provided, delay, transmit time, jitter, etc. is also a network layer issue. So even these are the extra network layer issues. Network layer provides two types of services to the transport layer. So network layer, we saw that what is network layer doing? Network layer is network layer receives services from data link layer, that is what your layer number 2, and provides services to the transport layer. That is your layer number 4. So what kind of services are provided? There are two types of services: connection oriented services and connection-less service. So connection oriented service. In connection oriented service, a connection, that is a path, from the source to the destination must be established before any data packet can be sent. So you need some kind of connection from the source to the destination before any kind of data packet is sent. A virtual circuit, sometimes called as a logical circuit, is a path between two or more points that seems like a fixed physical path but actually is one path out of many possible physical paths that can be arranged. This connection is called virtual circuit and the network is called virtual circuit network. So you can provide connection using a virtual circuit and the connection which is provided between the two networks is called as the virtual circuit and the network is called as the virtual circuit network. Next is your connectionless service. A connectionless service is just packet switching where no connection path established and release occurs. A message is broken into packets and each packet is transferred separately. So a message, what do you mean by this? A larger message is broken down into packets, that is smaller chunks of data, and each packet is transferred separately. The packets can travel through different routes to the destination since there is no connection. Here packet is called datagrams and the network is called datagram networks. In connection oriented service, your connection was called as virtual circuit, network was called virtual circuit network. Here the packet is called datagram and the network is called as datagram network.